For the second part of this lesson, we'll use transformations to sketch graphs. So by considering a rule for a graph as a combination transformations of a more simple rule, we can readily sketch graphs of many apparently complicated functions. So what we're going to do is sketch this hyperbola here by considering first the basic hyperbola. So the basic hyperbola, recall, looks like this: asymptote along there and asymptote along there. Now, what we'll do is we'll read off the transformations, okay, or consider the transformations. Now, this negative means it's a reflection in X. I'm not going to write them out officially. I'm just going to quickly shorthand them down here. This 4 means it's a dilation factor 4 from X. This means a translation 5 to the left and translation 3 up. There's the bell. All right, so what we'll do then is we'll concentrate on these and this, and that will take care of itself. Let me explain. So let's first of all translate 5 to the left. So what that is going to do is translate this vertical asymptote 5 to the left. So grabbing my line tool and grabbing a dotted line, I'm going to go 5 to the left, which will take me to -5. And 3 up will translate the horizontal asymptote 3 units up. So instead of being at y equals 0, it's going to be at y equals 3. Let's label those asymptotes. So that is x is equal to -5 and y is equal to 3. Right, this negative means that typically the hyperbola would go there and there. So this one here, that part there will be reflected to be down here, and that part there, or this part which would be here, will be up here. Okay, so let's get an x-intercept and a y-intercept, and what will happen is the x-intercept will be somewhere here, the y-intercept will be somewhere here, and then we'll just use symmetry to sketch this part here. Okay, so we'll note that the x-int occurs when y is equal to 0. So let's 0 equals -4 over x plus 5 plus 3. So what I'll do is subtract 3 and multiply by x plus 5 all in one move. Equals, what's that number? -4. Okay, so x plus 5 equals 4 on 3 by dividing 4 by 3. Okay, and subtract 5 off that will mean that I'm doing x equals 4 on 3, take away 15 on 3, and x equals -11 on 3. And to help us plot that, that's going to be x equals -3 and 2/3. Okay, so here is -1, -2, -3. 3 and 2/3 is somewhere there. Okay, the y-int occurs, of course, when x is equal to 0. So we're going to pop x equals 0 into the function. Then we're going to get y equals -4 on 5 plus 15 on 5. And that is going to be, what's that, 11 on 5, or 2 1/5. Okay, so here's 1, here's 2, here's 2 1/5 right here. Okay, so you're going to do a hyperbola through those points there, and then match it for symmetry there. Now, I'm going to attempt to do it, but those who I have taught last year will know that I operate on this little pad that goes next to the computer, and this is one of the weaknesses of the pad, is I have to draw this without actually drawing directly on the screen, and the pad is a little sensitive. So here's my best effort at it. You need to do better than what I produce though. It's going to be smooth in this. Mine is jittery, but I've got to go slow. Oh, that is just awful. Okay, so there's probably a tool that allows this to be smoothed out or something, but Okay, so make sure you go through that point there, not like I've done. This is 0, 11 on 5. This is negative 11 on 3, 0. Right, and then what we'll do is we just look at the rough symmetry there. So there looks roughly symmetrical for the other one. Right, so notice that we didn't really consider the dilation factor 4 from x. We're not really worried about the dilation because once I get the x and the y-intercept, it does take care of the dilation for us. So again, what we do is the translation, these are the basis of our sketch. The reflection tells us what happens to the basic and allows us to predict where the x and y-intercepts will be, and the dilation takes care of itself. So these ones, translations are the important. Right, go to the next one. So sketch the graph of this by considering root x. Okay, so root x is that. And what we'll do is, I'm just going to rewrite that equation to look as follows. Negative x, take 4, take 5. Now, what this allows us to do is to see the transformations a little better, or make it a little clearer. So you can see reflection in x, reflection in y, translation 4 to the right, and translation 5 up. Okay, so what we'll do is we'll use the translation 4 right and trans 5 down to commence the sketch. So 4 to the right, so that takes the 0, 0, or this point here. I sometimes refer to it as the anchor point, but that's not a technical term. So 4 to the right and 5 down is somewhere there. Yep, there it is there. All right, and which way is it going to flick? Is it going to flick that way, that way, that way, or that way? Well, we can get a y-intercept to help us. But I think the best thing to do is to see what these reflections will do. So a reflection in the x, so there's the standard flick, okay? This is a reflection in the x-axis, and this is a reflection in the x and the y-axis. So it's basically going to flick down this way. So I know that the y-intercept will be -8, between -8, probably -10. So let's do that. So what I'm going to do is sub x equals 0 to get the y-intercept. So 0 goes in, that is -4. -4 when negated is 4. 4 square rooted is 2. 2 negated is -2. -2 take 5 is -7. So it's there. 0, -7. All right, here goes my attempt. That's not bad. All right, remember that this is a key feature. So 4 to the right, 5 down. 4, -5. Right, so again, notice that that's just a great way of knowing what the basic does, what the transformations do, and anticipating whether you're going to get x-intercepts, y-intercepts, etc., etc. So you note that if I had to solve for x, that is, find the x-intercept, you should do that. Try to find the x-intercept. I know it doesn't exist, right? You can see there that this is never going to hit the x-axis, but try to run the algebra on it and just see what or how the function kicks back at you. It'll be an interesting exercise. All right. Oh, this last one's such an important skill. Okay, so what we've got is a function, f of x here, and it goes through the points -6, 0, 0, -8, and 10, -10. And what we want to do is these three transformations on it. Okay, I'm going to zoom out a little bit. No, I'm not. All right, one more time. Okay, so let's first of all do y equals f of 2x. So this is, by recognition, a dilation factor half from y. And dilations from y change the x values. So here we've got -6, 0. So that is going to halve the x value here. So that'll be -3. The y value stays the same. So it's going to be -3, 0. This one here will halve the x value, which is already at 0, the y value stays the same. So it's going to go through that point there, this point here. This one here, this is going to halve the x value. So that would be 10. We're going to say that this is 5, 0. Thus, this point here will be 5, -10. All right, and we've got our sketch. Again, can I ask that you please make sure that that's nice and smooth? Okay, so that is that one there. Okay, next one. What we've got is a reflection in the y-axis and a translation 1 unit down. So reflection in y, 1, so trans 1 unit down. Remember, I'm just using shorthand to remind myself here, but if you're actually stating officially the transformations, make sure reflection in the y-axis, translation 1 unit down. Use the full words. Okay, so reflection in the y-axis. Sorry, girls, about that. Just want to make sure you're feeling at home, though. So I think the bell's going to go in another 2 or 3 minutes again. So apologies. Okay, so what we're going to do, reflections in y change the x value or negate the x value. So what will happen here is that this here, -6, 0, is going to go to +6, 0, and then 1 unit down. So let's say that 1 unit down is roughly there. That's going to be 6, -1. So the x value gets negated to flip it over here. The net effect, you notice, is a reflection in the y-axis, and then 1 unit down. All right, this point. So the x value gets negated, and we go 1 unit down. So 0 gets negated, which stays at 0. -8 goes to -9. So we're going to put a point there, 0, -9. So far we're going through there. Right, this last point here is 10, -10. So what we're going to do is flick over to this side. So that's going to be -10, -10, and we're going to go one more down. We're going to say that that is -10, -11. All right, here we go. Okay, so again, make sure that it's just one nice long continuous function, no scrappy join points and things like that. All right, finally, this one here, this negative sign is a reflection in x. It is a dilation half from x as a trans 4 up. Okay, so I just take care of each one of those one at a time. So reflection in the x-axis negates the y values. So that's going to be 0. Dilation half from x will multiply the y values by a half, and 4 up will mean that that becomes, so this should be -8, this is +8, somewhere here. So it's going to end up at -6, 4. Okay, 0, -8. All right, so reflection in the x-axis will negate the y value. So that's going to go to +8 up there. Dilation half from x, so it's +8, +4. Yep, so halving that y value. I have to really think here. Okay, so that's going to be 4, and then 4 up, it's going to go to 8. So that's going to be 0, 8. Okay, let's just double check that. So reflection in the x-axis will take the coordinate point 0, -8 to 0, 8. Bang, goes up there. Dilation factor half from x multiplies the y value by a half, so that becomes 4. 4 up takes it to 0, 8. All right, so that's right. So far we're going through there, so I can predict that the next point will be somewhere up here or something like that. All right, so net 10, -10. So that is going to be a reflection in the x-axis, so we're going to have 10, 10. So we've swapped somewhere up here. Then it's going to be 10, 5, and 10, 9. There it is there. Right, let's sketch it. Now the scale is a little bit iffy here, but you hopefully get the point. All right, so there is sketching there. This skill here is so important. They base several difficult questions on this idea. Okay, so you'll be using this in integral calculus and all sorts of other areas. So very important skill. All right, so the second stage of the homework will be to complete the 3F questions there. Good luck.